Ma'am, wait. Let us wait for 1 more minute.
Okay.
കേറിയൊന്നുമില്ല പത്തി.
Good morning, all. I invite Professor Minshia for the welcome speech.
Hello. Hello.
Minshia, ma'am. Hello. 1 minute. Please wait.
Do you hear me? Respected Principal, Dr. Amira Yu, and today's resource person, Dr. Reshma Silverstein, and HOD of Chemistry, so, Ms. Soumya CC, and my dear colleagues and dear students. A warm welcome to the program conducted by the Department of Chemistry. Today, the Department of Chemistry, MESPNI College is organizing a lecture on antimicrobial resistance, the silent pandemic, in association with IEDC and IIC. My duty is to welcome the gathering. Without consuming valuable time, I wish to do my duty. First of all, I wish to welcome the principal, Dr. Amira Viyu, the vibrant and energetic principal of MES Pannani College, to this function. As we know, that today's lecture is focused on the antimicrobial resistance and its impacts on health. I think the topic is new to many of us. We are lucky to have Dr. Reshma Silverstein, an eminent microbiologist, with us. She focused her studies in this topic and hope she will give a clear picture in this topic. I take this opportunity to introduce our resource person, Dr. Reshma Sylvester. Professionally, she is a microbiologist with more than 10 years of research experience in the area of antimicrobial resistance. Presently, she is a postdoctoral fellow at the School of Industrial Fisheries, Cochin University of Science and Technology. He secured his PhD in microbiology from Cochin University of Science and Technology in 2018. Her research title is Genotyping, Virulence, Characterization and Survival Kinetics of Vibrio spp from Food and Environmental Source along southwest coast of India. She secured his MSc in Applied Microbiology from the University of Madras in 2011 and BSc in Microbiology from Mahatma Gandhi University in 2009. He also worked as a consultant in Veterinary Medicine Directorate UK from 2021 to 2022. And she also works as a research analyst at the Center for Disease Dynamic Economics and Policy, India, in 2018 to 2019. She also honored with many awards like Chief Minister's Navakerala Postdoctoral Award of 2022 to 24, University Postdoctoral Award 2019 to 22, UGC Basic Scientific Research Junior and Senior National Research Fellowship 2013 to 17, and Department of Science and Technology International Travel Awards 2017 and 22. She also secured Indian Council of Agricultural Research NET in Agricultural Microbiology in 2013 and Graduate Aptitude Test in Engineering Life Science 2015. She has 28 publications in international and national journals with a total impact factor of 115.25, and she has 742 citation invited talks, Embark 2022 webinar, and Geotax 2021. He also has 10 paper presentation in his credits, and he served as a reviewer of many journals like Science of the Total Environment, Marine Pollution Bulletin, Aquaculture, Future Microbiology, Ecotoxicology, and Environmental Safety, Journal of Environmental Biology, Regional Studies in Marine Science, African Journal of Bacteriology. Also has many membership in many societies like Canadian Society of Microbiologists, American Society of Microbiologists, and UK Microbiology Society. With these few words, I welcome Dr. Reshma Silverstein to this function. And I also wish to welcome our beloved HOD, Miss Soumya CC to this function, and I welcome all the colleagues and my dear students and my dear students to this function. Thank you.
Thank you, Minshia, for the excellent introduction. Shall I start my presentation?
Yes, ma'am. You
Okay.
can start.
Can you see my screen?
Yeah, screen is visible. Yeah, screen is visible.
Is it moving?
Yes, it is moving.
Okay. So good morning, one and all. Today I'll be talking to you about antimicrobial resistance, the silent pandemic. So I know you guys are not from a microbiology background, so I'll try to make it as simple as possible, and I really hope by the end of the talk you'll get at least a basic understanding about this topic, that is antimicrobial resistance. So with this, I'll start. So first of all, what are antimicrobials? Have you heard about this term antimicrobials before? Anyone? Do you know what are antimicrobials? Okay, so I'll tell you. Antimicrobials, they are those medicines which are used to prevent or treat infections caused by microorganisms in humans, animals, and plants. So just like we humans get infected with a microbial infection, similarly, even plants and animals are also infected by these microorganisms. And antimicrobials are medicines which are used to treat these infections. And we all know that microorganisms are of different types like bacteria, fungi, virus, etc. So depending on the type of function, antimicrobials are further classified into different types. For instance, antibiotics, which are also known as antibacterials. It is mainly used to treat infections caused by bacteria. Bacterial infections such as urinary tract infections, tuberculosis, or bacterial pneumonia, etc. An example of an antibiotic is cefodem or amoxiclav, etc. And I hope you would have heard about this amoxiclav and cefodem at least once in your lifetime. Similarly, antifungals are used to treat infections caused by fungi and various infections like various skin infections or at least food, etc. An example of an antifungal is the famous Candid B antifungal cream. Similarly, antivirals, they are used to treat or prevent infections caused by viruses such as cold, flu, chickenpox, COVID-19 or HIV. An example here is the remdesivir. You would have all heard about this antiviral drug remdesivir during the COVID-19 pandemic because it's commonly used to treat the COVID-19 infection. Similarly, antiparasitics, which are used to treat the parasitic infections like malaria. And now we know what are antimicrobials, right? So what is antimicrobial resistance? So just like the term suggests, antimicrobial resistance is the ability of the microorganisms to resist those antibiotics which are commonly used to treat them. That is, when the microorganisms change or mutate over time and get to a point where they will no longer respond to those medicines which are commonly used to treat them. So they'll continue growing even this in the presence of that antimicrobial, and that antimicrobial will not be able to treat or kill these microorganisms. So this phenomena is known as a antimicrobial resistance. Now, in the current scenario, globally, these antimicrobials are widely misused or overused in humans, animals, and aquaculture sector. Because of this, there has been a rapid emergence of antimicrobial resistance across the globe, and WHO or World Health Organization has declared this antimicrobial resistance as a major global health issue because of the huge clinical, public health, and economic implications caused by this particular phenomenon. And it's declared as a one health problem because it affects the health of humans, animals, and environment equally. and it impacts all. That means it doesn't matter whether you are rich or poor or whether you are young or old, it affects everyone equally. And nearly 7 lakh deaths have been reported per year globally due to antimicrobial resistance infections. So it's high time we act together to combat or control the emergence of antimicrobial resistance. Otherwise, the future, if we don't act now, is going to be devastating. And it's predicted that by 2050, nearly 10 million deaths per year will be caused due to antimicrobial resistant infections alone. And this is the timeline of the discovery of various antibiotic classes. So as we all know, the first antibiotic, that's penicillin. Starting from penicillin, this is the timeline for discovery of various antibiotics. And currently we can see that the antibiotic discovery pipeline is almost void and dry, and it's very slow. Hence, if the situation prevails, we'll soon run out of the effective drugs to treat deadly infections. And what will happen is that it will lead to a post-antibiotic era, where the drugs which are currently available for us for treatment of various infections, they will no longer work. And the situation is going to be very serious. And what will happen is that then it will cause to treatment failures of diseases and finally even the death of the patient. So that shows the seriousness of the situation. Now, as I already mentioned, antibiotics or antibacterials are used against bacteria. So I'll give an example of antibiotic resistance here. So suppose this is a group of bacterial cells. We can see there are two types of cells. One is blue color and another is red color. So these blue color cells indicates antibiotic sensitive cells, bacteria. And the red one is the rare antibiotic resistant cell. So what happens is that suppose when we are adding an antibiotic, this antibiotic will kill all the sensitive cells, but the resistant cell will not be killed and it will remain. And what happens next is that this particular resistant cell will continue multiplying and multiplying, and it will take over the population. So now the whole population consists of only antibiotic resistant cells. So the next time an infection is caused by this particular bacterium and this antibiotic is applied again, what will happen is that this antibiotic will no longer work against this bacteria because it has become resistant to this antibiotic. This is known as antibiotic resistance. So antibiotic resistance happens when bacteria change and become resistant to the antibiotics which are commonly used to treat the infections they cause. Now, what are the various causes of antibiotic resistance? So first is the overprescription of antibiotics or overusage of antibiotics. I'm sure many of you would have had common cold or flu at least once in your lifetime. So I've seen many people immediately run to a nearby pharmacy store and then buy some antibiotics and start taking the antibiotics when they get a cold or flu. But why? Because common cold or flu, it is caused by virus. It's a viral infection. And why do you need to take antibiotics for a viral infection? But because of the lack of awareness, there are many people who take antibiotics even unwantedly, even for a viral infection. So what will happen is that when these antibiotics are used unwantedly, the bacteria present in the environment and inside our body, it is getting exposed to this particular antibiotic. Right? So what happens is that the next time when an infection is caused due to this particular bacteria, and when we are taking this antibiotic again, what happens is that this bacteria would have already, since it's exposed to this antibiotic, due to selection pressure, you would have heard about this term natural selection or survival of the fittest. So what this bacteria will do is that when it's getting exposed to that particular antibiotic, it will try to develop some mechanisms to withstand and survive in the presence of antibiotics. So next time when an infection is caused by this particular bacteria, and again if we are taking the same antibiotic, there are many chances, means in the majority of the case, these antibiotics won't work against this bacteria because it's already exposed unwantedly to this particular bacteria previously and it has become resistant. So this shows how serious it is, and we should stop using antibiotics unwantedly for treatment of viral infections. Now, the next cause is patients not finishing the treatment. So suppose you're getting a pneumonia, bacterial pneumonia. What will you do? You'll go to a doctor, you'll consult a doctor, right? And then the doctor will prescribe you, suppose the doctor is prescribing you a 7-day course of antibiotic. And by the third day, you're seeing, okay, I'm feeling better. I no longer have the symptoms. So maybe, why should I take the antibiotic again? Even though it's a 7-day dose, by the third day, I'm okay, I'm perfectly fine. So I know I need not take the antibiotic again. So you'll stop the course in between. So this is a severe mistake. You should never do that. So even if even if you're feeling better, that doesn't mean all the bacteria that has caused this particular pneumonia has vanished or has been removed from your body. So what happens is that remaining bacteria will continue multiplying in your body, and there are many chances you will get a reinfection due to this bacteria which was remaining in your body because you stop the course in between. So never stop a course of antibiotic in between, even if you feel better. So take the advice of the doctor and complete the course. Otherwise, you're going to be affected, and reinfections can occur. Okay, now next is the overuse of antibiotics in livestock and fish farming. So just like antibiotics are widely used or misused in humans, similarly, antibiotics are widely used by the farmers in livestock production and fish farming in order to treat infections or prevent infections. And even if the infection is a viral infection, antibiotics are used. So again, it's because of the lack of ignorance, and this will cause the emergence of antimicrobial resistant bacteria in the aquaculture and livestock farming sector. The other causes of antibiotic resistance are poor infection control in the hospitals and clinics, lack of personal hygiene and poor sanitation, and lack of new antibiotics being developed or coming into the market. Now, COVID-19 and AMR. So I'm sure you would have all heard about COVID-19 pandemic for past 3 years. We are struggling with this. But how does COVID-19 contribute to AMR? So reports state that COVID-19 pandemic has activated the antibiotic usage globally, and this has in turn led to rapid increase in antimicrobial resistant microbes across the globe. And antimicrobial resistance is usually referred as a silent tsunami or silent pandemic because it is being this particular pandemic is being emerging very silently without being unnoticed and in an invisible manner. However, it is predicted to be the next global pandemic after our COVID-19 struggles. So this shows the seriousness of the situation. And this is a report where in the study they found that the early antibiotics therapy for COVID-19 patients was as high as 87.7%. That means 87.7% of the COVID-19 patients who were admitted in the hospitals were given antibiotic therapy. But why? Again, COVID-19 is caused by a virus, right? It's caused by a COVID-19 virus. And why are they giving antibiotics for COVID-19 treatment? Only when if you get a secondary bacterial infection, there are chances that the COVID-19 patient can get a bacterial secondary infection. So only to treat that, we need antibiotic. And in this case, we can find that only 6.9% of these hospitalized patients actually had bacterial co-infection. So this clearly shows nearly 80% of the antibiotic usage in these hospitals was unwanted. So such unwanted rapid use of antibiotics has further activated the emergence of antimicrobial resistance. And various newspapers has reported this. For instance, Science News, they have reported that, excuse me. Okay. COVID-19 has aggravated the antibiotic misuse in India, and News 18 has reported that the new pandemic is under construction in silence, that is antimicrobial resistance. And Indian Express has reported that antimicrobial resistance has increased due to COVID. So all these situations clearly reveals how the misuse of antibiotics is contributing to the emergence of antimicrobial resistance across the globe. And in India, the situation is very severe. Now, this is a recent study which I conducted as part of my postdoctoral research on global surveillance of antimicrobial resistance in Klebsiella pneumonia bacteria from low and middle income countries. So what is this Klebsiella pneumonia bacteria? It will be a new bacteria for you, I guess. So pneumonia, you would have heard about pneumonia, right? It can be caused either by virus or bacteria. So this particular bacterium, Klebsiella pneumonia, is the main causative agent of bacterial pneumonia. Okay. And so my intention was to find out the level of antimicrobial resistance in this particular bacteria from 33 low and middle income countries, including India. And a total of 2,432 Klebsiella bacteria was studied. And I found that all these bacteria, all the 2,432 bacteria were multiple antibiotic resistant. That means that they were already resistant to multiple type of antibiotics. And to add to the seriousness of the situation, a high prevalence of carbapenem-resistant bacteria was recorded from countries, especially India, Pakistan, and Vietnam. So what is this carbapenem antibiotic and what is its relevance? So this carbapenem antibiotic it's a last resort antibiotic or last line drug. That means this particular antibiotic is used to treat the pneumonia when no other antibiotics works, when no other drugs works. This is the final option for us. This is the last resort of final option for us. And if this antibiotic is also not working, means the treatment will be an utter failure and there are chances that you'll die because of pneumonia. And in my study, majority of these bacteria were also resistant to carbapenem. So this adds to the seriousness of the situation. And there are high chances if you are getting an infection due to carbapenem resistant, multiple antibiotic resistant Klebsiella pneumonia, there are chances their treatment will fail. So in order to make you actually understand the seriousness of the situation, I'll give you an example from my personal life. That is, one of my relatives, she had a kidney infection and she was admitted in the hospital. And in the course time, she started developing pneumonia. So the doctor immediately started the antibiotic treatment. However, her situation was becoming worse day by day. It was not healing and she was not feeling better. It was getting worse. And so the doctor changed the antibiotic and different combination of antibiotics were used, but nothing worked. And finally, the situation became very worse. And the worst thing happened, that is, we lost her. And the cause of her death was because of the antibiotic resistant Klebsiella pneumonia. And when her samples were tested, it was found that she was infected with antibiotic resistant Klebsiella pneumonia bacteria. And this led to a loss of one life. So now I hope you would have understood how serious the situation is. Now we have already seen how this antibiotic usage and antimicrobial resistance affects our human health. Now we'll look how it affects the environment. So this pharmaceutical industry has a major role in contributing to the environmental spread or dissemination of antimicrobial resistance. So pharma industry produces antibiotics, and India ranks third in terms of pharmaceutical production. And this pharmaceutical manufacturing sites in India are acting as a major hub for global antibiotic production. What happens here is that the pharma industries, they produce the antibiotics, and these antibiotics will be used in humans and animals for treatment, etc., etc. And majority of these usage will be unwanted for sure. And what happens is that after that, these antibiotics, unused antibiotics or the antibiotic residues will be disposed to the surrounding environments through sewage or hospital waste or human waste or animal waste. So these antibiotic residues, it's very difficult to degrade them. So they'll come and they'll get deposited in the environment. So when in the environment, what happens is that environment contains many bacteria, including pathogenic bacteria, which can cause human and animal infections. And when these antibiotics are being exposed to this bacteria, in order to survive this in the presence of antibiotic, they'll try to develop mechanisms to resist these antibiotics, and finally emergence of antimicrobial resistance occurs. So that this is how the pharmaceutical industry contributes to emergence of antimicrobial resistance in the environment. Similarly, the untreated pharma effluents, majority of them, they are discharged directly to the environment. So it's high time proper rules and regulations and actions should be taken to stop this unwanted spread of disposal of antibiotics to the environment, which causes a severe threat to the emergence of antimicrobial resistance. Now we have seen the contribution to humans and environmental health. Now we'll see the animal production sector. Recently, there has been an increased global demand for animal-based proteins to meet the protein supply of the increasing global population, which has led to a rapid intensification of the animal food production sectors across the world, where antimicrobials are widely misused or overused. which in turn has led to rapid emergence of antimicrobial resistance. This chart shows the top 10 consumers of veterinary antimicrobials by country, and China is the largest consumer of veterinary antimicrobials, and India stands fifth. Regulations are in place on the usage of antibiotics in the animal production sector in developing countries, including India. So thus, these intensive food production sectors can act as a fertile ground for emergence of antimicrobial resistant related pandemics. So this was a recent study which we conducted where we tried to analyze the status or trend of resistance in animals from low and middle income countries, including India. So the major animals, that is cattle, chicken and pigs, were taken and samples were collected from them, and then the bacteria collected from these animals were tested for the antibiotic resistance, and it was found that high to moderate level of resistance to most clinically relevant drugs. Clinically relevant drugs means those drugs which are used in treatment of infections, mainly in humans. So these bacteria were resistant to many of the clinically relevant drugs. And the hotspots for antimicrobial resistance were identified as India, China, Pakistan, etc. Hotspots means the countries where the level of antibiotic resistant bacteria was the highest. So again, India stands among them. So this seriously shows how badly India is affected due to antimicrobial resistance. Now, next coming to antimicrobial resistance in aquaculture sector. So this is my area of research specialization. So I have been working on surveillance of antimicrobial resistance in aquaculture sector mainly. So I'll be talking about this in some detail. So aquaculture, or the farming of aquatic animals like fish and shrimp, is one of the fastest growing food production sectors in the world currently compared to other animal production sectors. However, 90% of the world aquaculture production is confined to developing countries like India, which lack proper regulations and enforcement on the usage of antibiotics. However, in the developed nations, they have more stricter regulations and only few antibiotics are licensed for use in aquaculture. Hence, this rising tide of antimicrobial resistance in aquaculture is a major concern in low and middle income countries, including our country, that is India. So now I'll explain the various pathways through which the antimicrobial resistance is emerging and spreading in a typical small-scale aquaculture farm. So first is the direct usage of antibiotics. That is the direct unregulated usage of antibiotics into the farm by the farmers, which leads to emergence of AMR. Next is AMR can be spread or can enter the farm from the adjoining environments. So while mixing the fresh water with salt, to adjust the salinity of the farm water, the farmers may take the natural water from a nearby river or pond and adjust the salinity. So what happened here is that suppose if these water bodies are already contaminated with antibiotic or antibiotic resistant bacteria, they will also enter the farm. Similarly, when the human and animal waste are used as pond fertilizer in the farms, this way also antibiotic resistant bacteria or the antibiotic residues can enter these farms. Similarly, from the farm, antibiotic resistance can enter the humans. For instance, when the farmer, we can see the farmer is working in the farm, so he is being in direct contact with the shrimp, pond water or sediment. So there are chances that the farmer can get infected. Similarly, when the pond waste is used as chicken fertilizer or to chicken feed or as fertilizer to the adjoining agriculture crops, what happens is that this AMR bacteria, antibiotic resistant bacteria, finally enters us, that is humans, through the food chain. And finally, from the farm, this AMR bacteria and antibiotic residues can also enter the environment, that is mainly by release of the untreated waste. Majority of the farm waste is untreated and is directly discharged to the nearby water bodies, this thereby contaminating the environmental compartment also. And finally, the product, that is the shrimp or fish which enters the food chain, can cause significant risk to the global antibiotic dissemination as well. Due to all these, aquaculture farms are generally regarded as genetic reactors or hotspots for antimicrobial resistance. Now, this is a recent study where they tried to find what was the level of antibiotic usage in the aquaculture sector. And it was found that the highly important and critically important antimicrobials contributed to nearly 96% of the total use. It shows that antibiotics are widely misused across the globe in aquaculture production sector. Now their next intention was to check. Now they have already found that antibiotic usage is very widespread. Now they wanted to check whether this antimicrobial antibiotic usage in the aquaculture farms has contributed to emergence of antimicrobial resistance in these systems. And it was found that a high level of antibiotic resistant bacteria were reported from these aquaculture and fishery environments in the Asian countries, including India. So this shows the direct correlation between the usage of antibiotics and emergence of antimicrobial resistance. Now, this is another study which I conducted as part of my PhD work, where I tried to find the antibiotic resistance among Vibrio bacterium isolated from Cochin estuary, a shrimp farm located in Cochin, and seafood collected from the local fish markets in Cochin. A total of 280 Vibrio strains were taken. So what is this Vibrio bacteria? This particular bacteria is the causative agent of cholera, dysentery, diarrhea, seafood-borne infections, etc. And majority of mice of these strains were found to be multiple drug resistant. And they were also resistant to clinically relevant drugs. So what happens is that there are lots of chances when you're taking a seafood which we get from the market or from the adjoining shrimp farm. There are lots of chances if this particular bacteria is there, you can get infected and the antibiotics may not work. So it's highly recommended that you cook the seafood properly, because if you're cooking the seafood properly, this bacteria will get killed and hence you may not get an infection. So you should completely avoid taking raw seafood or partially cooked seafoods. Now we have seen the various clinical and human implications of antimicrobial resistance. Now we'll see what are the economic implications. So these data, it shows that the shrimp exports from low and middle income countries, including India, which is shown as blue, which are rejected by European countries and USA due to the presence of banned antibiotics in them. So detection of banned antibiotics like chloramphenicol and nitrofurands in internationally traded shrimp has resulted in export rejection, causing huge economic loss to the farmers and to the government's economy as well. So this is how the antibiotic usage affects our economy. And we can see the majority of the rejections were from India, which clearly shows that antibiotics are widely misused in the shrimp production in the aquaculture sector. Now, this is an international agency, that is React Asia. They conducted a awareness raising program for the aquaculture farmers in Kerala, where they tried to find out the perspectives of the farmers and the usage of antibiotics in the aquaculture farms. And majority of the farmers, it was shocking to see that majority of the farmers, they revealed that they are using antibiotics in their shrimp farms, even though most of the diseases are due to viral diseases. So this clearly shows the ignorance or lack of awareness among the farmers. And however, they revealed that the shrimp meant for export market, in those shrimps, they rarely use or they don't use antibiotics at all, because as I already mentioned, there are chances of export rejection. So fearing the export rejection, these farmers don't use antibiotics in these farms. However, in the shrimps meant for local market, that is the shrimps which we all are consuming. Okay, so in these shrimps, antibiotics are still widely used. The farmers have clearly revealed that. So this is a serious situation. So these farmers were given proper awareness and they were made to take 10 commandments of an antibiotic smart farmer, like they'll take antibiotic as a valuable resource and they'll not use antibiotics unwantedly, etc., etc. So now it's high time necessary actions are taken to tackle antimicrobial resistance. For that, well-conceived legislation and regulations are needed. An integrated global antimicrobial resistance surveillance system is needed. Proper awareness raising activities and public engagement activities should be conducted in order to raise awareness among the general public, and good practices should be followed, etc. In short, proper awareness, good surveillance, good governance, and good practices should be followed to stop the spread of antimicrobial resistance. And coming to various action plans, So globally, various countries have started implementing action plans to control or solve the issue or stop the emergence of antimicrobial resistance. The India government in 2017, they have come out with the National Action Plan on Antimicrobial Resistance. And as a follow-up, the state of Kerala was the first Indian state to launch an action plan for antimicrobial resistance. And this action plan is commonly called as CARSAP, and it was implemented in 2019. And we should be proud about that. We are the first Indian state to come out with a state action plan. Now, along with the action plans, we also need various alternative approaches which can reduce our dependency on antibiotics. So antibiotic alternatives which we can be used include probiotics. Probiotics, you would have heard about probiotics. They are a collection of living or live good bacteria that helps to keep your body healthy and working well. This way, it can prevent infections and it can boost your immunity. Only if an infection happens, you need to take an antibiotic, right? So this helps us to keep our body healthy. Examples of some probiotics include yogurts and Yakult. These are commonly available in our supermarkets. And similarly, probiotics are also available for the aquaculture also. For instance, AquaProb, it's a probiotic commonly used in the aquaculture farms. Another alternative option for antibiotic is immunostimulants, which can boost the immunity, thereby preventing infections. Similarly, use of vaccines. You would have all heard of vaccine after the COVID-19. So vaccines are used to prevent infections. As we always say, prevention is better than cure. So vaccines can prevent an onset of infection, so as thereby reducing our usage of antibiotics. Now, antimicrobial resistance, don't think it's a problem of microbiologists alone, or it's concerned only about microbiologists. It's a global problem, and it is an interdisciplinary subject. You should know that it is an interdisciplinary subject. So experts from all fields of life sciences are needed to combat the issue of antimicrobial resistance. So this is where the role of chemistry people also come. Even new people have a role in contributing to this solution. For instance, you can come out with the development of some antimicrobial peptides. These peptides which can kill the bacteria or virus or fungus. This way you can develop a new compound. For instance, in our university itself, there are people from biochemistry who are trying to extract compounds from soil or from plants or animals which has antimicrobial property. So these compounds can be used. So first what they will do is that they'll extract different compounds and check for the antimicrobial activity, and then they'll screen those compounds which have antimicrobial activity. And then it will be next level will be the trials, clinical trials. So first animal models will be used for the trials, and we'll check whether these particular compounds are toxic or not. And then human trials will happen. And if this particular compound passes all these clinical trials, finally they can come out, patent the product, and they can come out with a new compound or new product which can be used instead of antibiotics to treat or kill these bacteria, virus and fungus. So you chemistry people can very much contribute this particular finding alternative compounds for instead of antibiotics which can kill microbes which has antimicrobial activity. Similarly, bacteriophages can be used. It is currently one of the most promising solutions. They are viruses that attack bacteria. So we should note that though they are viruses, they attack only bacteria. They don't attack humans or animals. So it's totally safe to use this as an antibiotic alternative in treatment of various infections. For instance, Salmofresh, this is a bacteriophage product which is used to effectively treat salmonella. Another example is Encobacteriophage. These are all available in the markets now. Now, these are few of the bacteriophage products which are currently used in the animal production sector globally. Similarly, antibiotic alternatives can be also used in human treatment. And recently, India government has introduced phage therapy for treatment of infections in India also. So some of the recent milestones in the development of antibiotic alternatives in aquaculture. So the University of Stirling have come out with a new vaccine which can be used against the fish rainbow trout. Similarly, Stim, it's a biotech company. They have come with different products, bacteriophage products, which can be used against a fish in the salmon instead of antibiotics. And recent milestones from CIBA, that is the Central Institute of Brackish Water Research. They have developed an indigenous bacterial vaccine which can be used in the sharks. And similarly, they have come out with a new vaccine which can be used as an antibiotic for fish. So, though antibiotic resistance is very severe, these success stories gives us an assurance that we still have a ray of hope left to combat this issue. For instance, Norway's fishing industry is often cited as a good example of how an aquaculture sector should run. And they were able to cut down the antibiotic usage in their salmon fish farms to virtually zero. This was achieved by properly vaccinating the salmons and using bacteriophage therapies in their farms. In another example, in UK salmon farms, the antibiotic usage was reduced to nearly 60% recently by properly following vaccination programs. So such programs and activities can be conducted even in our country so as to reduce the dependency of antibiotics. So I believe that we all as individuals have an equal role to contribute to combating the global issue of antimicrobial resistance by relying on antibiotic alternatives, as I already mentioned, and using antibiotic wisely, precisely, and only when needed. You should completely avoid unwanted or overuse of antibiotics. So let us all start taking our tiny steps to achieve a vision that is a world in which antimicrobial resistance is effectively contained, controlled, and mitigated. And I would like to conclude by quoting the famous saying by Sir Alexander Fleming. I'm sure you would have heard of Sir Alexander Fleming. He is the inventor of the world's first antibiotic, that is penicillin. So the thoughtless person playing with the penicillin treatment is morally responsible for the death of the man who succumbs to infection with the penicillin-resistant organism. So let us all start trying to combat this issue. And as chemistry people, you should also contribute your best to this issue by trying to develop new compounds or new antimicrobial peptides or bioactive compounds which can be effectively used against these microorganisms. Thank you so much for your attention. And I hope you would have got at least a basic understanding about antimicrobial resistance after this talk.
Thank you, Reshma ma'am. Thank you for the valuable information. And it is, as I already mentioned, it is a new topic to many of us, including me. And but you present it very nicely and in a simple manner. I think most of them are get an idea, basic idea about
I
what is
hope you would have got
antimicrobial resistance. Okay, it is a time to discussion or clarifying the questions or queries which the participants may have. Any of you have any doubts regarding this topic? Please clear it from with the Reshma ma'am. Ma'am, I have a doubt. This is general. It is a common man doubt because, as already you mentioned, that the doctors or physicians prescribe a lot of antibiotics for us, even for a common fever, and even for newborn babies too. Is it acceptable or is it a good practice to complete the course? It is necessary to complete the course. Doctors already advise that it is necessary to advise the course of the medicine. Is it good for the health to complete the?
you have to complete. See, if the doctor, first of all, and antibiotic prescription, doctors are being given like necessary awareness so that they don't prescribe, as I mentioned in COVID-19 case, they should not prescribe the antibiotics unwantedly. But if it is a bacterial infection, and if the doctor is giving a course, if it's a 7-day course or a 3-day course, you should complete the course. If you're stopping it in between, it will be very dangerous. You should never stop it in between.
Okay, okay. Is a COVID, if a person is affected with COVID-19, is there any chance to antimicrobial resistance to develop
Yes, yes, there are
in
lots of
the
chances because I've seen that in the COVID-19 situations, the moment the patient is positive for COVID-19, I've seen doctors asking them to take the azithromycin or cephodam, start taking that. Actually, these antibiotics are needed only when this particular patient has got a secondary infection or pneumonia or some symptoms of pneumonia. Then only this antibiotic is needed. But in many cases, doctors are prescribing the asking the patients to take antibiotics even unwantedly, especially in the COVID-19 situation. So this leads to emergence of antimicrobial resistance. What happens is that we are taking this antibiotic during COVID-19. It will be maybe 2 weeks. We'll be taking this, and next time, if you are getting infected with that particular bacterium, there are chances that that antibiotic may not work for you. You'll have to look for another options.
okay. Does AMR affect our immune system?
AMR doesn't see when you're less immune, there are more chances that you will get the AMR infections. Okay, if you're immune enough, your body can fight these infections. It doesn't affect your immunity, but if you're immune, if you're really immune enough, you can prevent the infection.
Thank you, ma'am. Any of you have any doubts or queries? Okay, I think as it is a new topic and
I hope you'd have got at
the
least some idea about it. I'm not sure. I was worried
okay.
because it's a chemistry background. I don't know how you
Yeah,
have
okay.
understood it.
Excuse me, madam.
Yes.
Madam, this antimicrobial resistance is permanent or it can be reversed?
Now there are like many experiments in which they are trying to reverse the. See what happens in an antimicrobial resistance is that bacteria develop some mechanisms. So suppose you'd have heard about bacterial cell wall, right? Cell
Yes, yes,
wall.
yes, yes.
Cell wall. So some of these antibiotics like penicillin or amoxiclav, they how they act is that they degrade this bacterial cell wall. They'll break the bacterial cell wall, and that is how they kill the bacteria.
Okay, okay.
Okay, so when a resistance happen means this bacteria will develop some mechanism to prevent this antibiotic from entering its body. It will pump out the antibiotics using certain pumps, or it will make some modifications on its cell wall so that that antibiotic can no longer identify this bacteria. So that is how they become resistant. So if these particular modifications are being removed, or if these pumps are removed, this bacteria will become non-resistant. But it's not easy to revert antibiotic resistance in the natural system. This can be done experimentally, but in the natural system where there is millions and millions of bacteria, it's not easy for us to pick each bacteria and revert its mechanism. Understood?
Okay, okay. Actually, this resistance due to some mutations of these
Yes,
genes.
yes.
Am I right?
Some mutations will happen in the gene, and so some modifications will happen in the cell. And these modifications will help the bacteria to prevent the antibiotics from entering its body.
Okay, madam. Thank you. Thank you.
Thank you, ma'am. Now I invite Fatima Shimna to express official vote of thanks.
Good afternoon.
Good afternoon.
It is highly privileged and honored to propose the vote of thanks. First of all, I would like to express my sincere gratitude to Dr. Amira VU, Principal of MES Panani College, for being our constant supporter in our path of progress. And now, I would like to express my heartfelt thanks to Dr. Reshma Sylvester for sparing her invaluable time with us. The session was very informative, and we are aware of the harmful threats against microbes in our body and environment while using antibiotics. And of course, it is a new information that even we chemistry people have a role in it. Once again, thank you for sharing this valuable information. And now I would like to thank Mrs. Soumya CC, HOD of Department of Chemistry, and Dr. Mujib Rahman, former faculty of MES Panani College. And I would like to thank Mrs. Minshia P for coordinating the program and all other teachers. And finally, last not the least, I would like to thank my dear friends for their wholehearted cooperation. Once again, thank you for all your attention.
Thank you, ma'am.
Thank you.
Ma'am, do you need any feedback or anything?
It will be good because it's chemistry background. I would like to know whether you have got at least some idea about this. So a feedback from the students would be really helpful.
Okay, we will share it.
Okay, thank you. I'll log out.
Okay.
Okay, thank you so much. Thank you.
Thank you. Welcome.